There were 4 important skills that you needed to have mastered to do well on the test. We'll go over those 4 skills in this video. The first is being able to name the slope that passes through 2 given points. The formula for slope says that it is the change in y over the change in x. In order to find the change from one y number to another, and then from one x number to another, we've been using a little mini table. We have our x coordinates on the left and our y on the right, and what we've done is we've placed each of the numbers, x coordinate -3, y coordinate 8, x coordinate 10, y coordinate 11, placing them into our table. Then we start taking a look at that change piece. How do I go from 8 to 11 using addition and subtraction? Well, I take 3 positive steps to go from 8 to 11, and to go from -3 to 10, I take 13 positive steps. So the change in y is equal to 3, and the change in x is equal to 13. If I go back over to my formula, the slope of this particular line is 3 over 13. I can't reduce, so there's my answer. Now, indicating whether it's positive or negative is pretty easy. If this is a positive number, this is a positive slope. If it's a negative number, it's a negative slope. If the slope equals 0, because there's a 0 in the numerator, then the slope is 0. The second skill was to be able to identify the pieces of an equation in slope-intercept form and then use that information to graph. I'm going to zoom in on the first part here because it actually tells us we need to put the following equation into slope-intercept form. A lot of students thought that this was already in slope-intercept form because the y was isolated on the left. In fact, it's not fully isolated. It's still being multiplied by 3. So in order to truly get this into slope-intercept form, we have to divide by 3. If I divide that term by 3, I also have to divide this by 3 and my -12 by 3. Those 3's cancel, and I have y equals 1/3 x minus 4. Now this is an equation in slope-intercept form because y is truly isolated on the left. I can use the information in the equation I created. My slope is always the number being multiplied by x, 1/3, and my y-intercept is this b number over by itself, and in this case it's -4. Now I can take this information and straight to my graph. -4 is this y-intercept, which means if I go down to -4 on the y-axis, starting at my origin, -1, -2, -3, -4, this is where the line is going to cross the y-axis. My slope was 1/3. The change in y is 1, and the change in x is 3. It's all positive, so that means I'll go up 1 in the positive direction for the change in y, and over 1, 2, 3 in the positive direction for the change in x. Here's the next dot on my line. I can go up 1 and over 1, 2, 3 again. And now I've got a pretty decent line on my graph. Write an equation in slope-intercept form that goes through the points -3, -6, and 7, -1. So we've got to combine some skills with this one. We've got the skill of finding the slope that we talked about in the first problem, and we're going to have to put that into play here. In every equation, at minimum, we need a slope. So we're going to create our little xy table. I'm going to take the point -3, -6, put it into my messy table, and the point 7, -1. Now I need to look for the changes. Slope is the change in y over the change in x. So let's start examining the change we have. We're going from -6 to -1, which is +5. Right? And we're going from -3 to +7, which is +10. It looks like our slope is change in y of 5 over change in x of 10, which I'm going to simplify to 1/2. You should always reduce the slope when possible. So my slope, is equal to 1/2. Now, if I knew the y-intercept, the b, I could go straight to slope-intercept form. But the only information I have right now is a slope and 2 points. And when I know a point on the line and I know the slope, I have to start with point-slope form. That's this monster one right here. Okay? I begin by just replacing the things that I know. I'm going to choose to use this point right here. You could really choose either one and we will end up with the same answer, but I'm going to choose this one because it's got at least one positive number. My y number is -1, so I am going to replace my y1 with a -1, and I'm going to replace my slope with 1/2. That's the information I got over here with my slope work. And I'm going to replace my x number with 7 from the point I circled up above. Now I've got some simplification to do. I have to multiply 1/2 times x and 1/2 times -7. I'm also going to simplify minus -1 into y plus 1. On this side, 1/2 times x is 1/2 x, and -7 times 1/2 I'm going to leave as an improper fraction. I'm going to leave it as 7 over 2. Now I have to isolate my y so I can get slope-intercept form. That's what the problem asked for. So I'm going to subtract 1 from the left, subtract 1 from the right, and I have y equals 1/2 x, and then I've got this somewhat messy fraction problem. So 7 over 2 minus 1. I'm going to come all the way around over here and do a little bit of fraction work. If I have -7 over 2 minus 1, I have to rewrite that in a way that I have common denominators. I know because of my knowledge of fractions that I can rewrite 1 as 2 over 2. It's equivalent to 1. I also know from pre-algebra that I'm going to need to keep, change this little fraction piece here. So I'm going to do that very quickly. And by the time I'm done, I have a denominator of 2, and I have -7 plus -2 is -9. I'm going to bring that back to my equation, and I have -1/2 x minus 9 over 2. In slope-intercept form, fractions, improper fractions, are just fine. That is my final answer. In this last problem, we have to identify if two lines are parallel or perpendicular. We learned in our notes that parallel lines have the same slope and that perpendicular lines have a slope that is the opposite sign and also the reciprocal. If I take a look at the first equation here, I see that it's in slope-intercept form already. It's easy to find the slope. I know that because the y is isolated on the left, which means that I can safely go straight to my slope, my number being multiplied by x of negative 1/3, and I can say that the slope of this line is negative 1/3. This line, however, on the bottom is not in slope-intercept form. It's in standard form. Standard form does not give any good information, so I've got to do some work. I'm going to rearrange it so that I can really identify the slope and then see what I'm dealing with. I'm going to start by getting rid of the x's on the left. And then to completely isolate y, just like in the beginning, we're going to divide each term by 9. Negative 3 over 9 is actually the same as negative 1/3. And I'm going to reduce 12 over 9. I'm going to divide the top by 3 and the bottom by 3 and get 4/3. The second equation in slope-intercept form is y equals negative 1/3 x plus 4/3. I can go here straight to my slope, identify that the slope is negative 1/3, and I can say that these two lines are parallel.